Hi everyone and welcome to my channel Depth First. In the first part of this video, I have explained the different approaches that you can take to solve this question, and I have also solved it in O of n log k time complexity. I would highly encourage you to go over that video first, and in this video, I'm going to solve the question in O of n time complexity, which is better than n log k. I'll read up the question. Given an integer array nums and an integer k, return the kth largest element in the array. Note that it's the kth largest element in the sorted order and not the kth distinct element. You must also solve it in O of n time complexity. So we'll be using the classic partition algorithm to solve it in O of n. Let's first take the time to understand what is the partition algorithm. Now let's pick a number. Let's say that number is the last element, which in this case is 4. So we want to partition the array in such a way that the numbers less than or equal to 4 fall on the left side or are placed on the left side, and the numbers greater than 4 are placed on the right side. And in the end, we want to return the index where this array was partitioned. So the numbers on the left and the right sides of the partition do not necessarily have to be sorted. They only need to be parted in such a way that the numbers less than or equal to 4 fall on the left side and the numbers greater than 4 fall on the right side. So it's quite beneficial to learn this algorithm because it can be applied to solving other important questions like quicksort or Dutch national flag. So I would highly encourage you to learn this. So our partition function will get two input variables as parameters. The first one is p and it points to the first element of the array. The second one is r and it points to the last element of the array. Since we'll be partitioning the element based on the last element, it is also referred to as the pivot. We'll use two variables to do the actual partition. The first one is j, and that is used to step through every element of the array from p to less than r. And the second one is I. So what does this variable I represent? The variable I points to the number of elements that we have found so far which are less than or equal to 4. As I advances in the array, it will always point to the last element we have found so far, which is less than or equal to 4. Since we have not found anything, variable I is set to one position behind p. So here is a look at the loop invariant of the partition algorithm and how it maintains the 4 different regions. The rightmost element is the pivot based on which we are partitioning. Let's say that value is x. So all elements between p to I would be less than and equal to x. So I essentially represents the last element of the partition. All elements between I plus 1 and less to j will be greater than x. And j points to the start of elements that have not been explored yet, and they're represented by gray colored cells. All right, so let's walk through the algorithm step by step. We have the 4 variables, and like we discussed, p and r will be provided as function parameters, whereas we'll be using I and j to do the actual partition. So pivot is the rightmost element, which is 4, and the pink line before p indicates the partition line, and all elements before that are less than or equal to 4. It will advance as the variable I advances. We will use j to enumerate or step through all the elements of the array. The first element that j points to is 2, and 2 is less than 4, so we will increment I. We will swap the element at j with the element at I, but since it's the same element, the value remains the same. So j now advances to the next element 7. 7 is greater than 4 and we do nothing and move j to the next element 8. 8 is also greater than 4 and we do nothing and move on to the next element 3. Now 3 is less than 4. So we will increment I, and then we need to swap the values of I and j. After swapping, we'll move j to the next element, which is 1. Since 1 is less than 4, we'll increment I and we'll swap the elements at I and j. We'll increment j to the next element 5, and 5 is greater than 4, so we'll keep it as is. And then we'll increment j to the next element 6, and 6 is also greater than 4, so we will keep it as is. So as you can see, we have partitioned the array where the elements up to I are less than or equal to 4, and the elements from I plus 1 to j are greater than 4. We now need to place our pivot element in the right spot. For that, we will increment I one last time, and then we'll swap out the values at r and I. And now our array is completely partitioned. We will return I from this function, and I indicates the last element of the partition. Let's review the partition function. The function takes 3 parameters, p, r, and the nums array. We will initialize the pivot to nums of r, and I is initialized to p minus 1. We'll use j to step through the nums array from p to r. If the value of the nums array at j is less than or equal to pivot, we will increment I, and then we will swap out the values at I and j. And finally, we will increment I, and then we'll swap out the values at the pivot with I, and then we'll return I from this function, and I indicates the last element of the partition. Okay, so how can we use partition to find the kth largest element? And that is pretty much the crux of this question. So this is the example that was provided, and k is equal to 2. Now, what if this array was already sorted? So the second largest element would be the second most element from the end, and that is 5. And what does that mean in terms of index? So it means that we are looking for a target index of length of nums minus k, which is equal to 4. So the element at target index 4 is the answer, which is 5. Now imagine this for just a few seconds. What if the numbers to the left of index 4 were not really sorted? So for example, if we just swap out 3 and 4, would it really matter when finding the answer? It won't, right? Because we'll still find the right number as long as the numbers less than 5 are placed on the left side. That means we don't need to completely sort the array. We just need to partition it correctly, and that's the property we are going to use. Let's go over how we'll partition this array to find the correct value. That should be at target index 4 or the second largest value. Now here is what the array will look like after we have run it through the partition function, and it returns the partition index as 3. Now 3 does not match our target index of 4, so we'll continue to search. Since our target index is greater than 3, we'll ignore the first half of the array and partition the second half. And here is what the array will look like after partitioning the second half. The partition index returned is 4, and that's what we're looking for. So we return the element at index 4 as the answer, which is 5. Let's now review the code. First, we'll calculate the target index that we need to find. We'll create an inner function called quickSelect, and we'll call that by passing 0 and index of the last element of the nums array as parameters. Inside the quickSelect function, if p is equal to r, that means there is only one element in the array, and we will return it. Otherwise, we will partition the array. The index returned after partitioning is q, and if q matches the target index, we'll return the element at the target index as the output. If q is greater than the target index, then we will recursively search the first half and we will ignore the second half. Otherwise, if q is greater than the target index, then we will recursively search the second half. The time complexity for this algorithm is O of n, and the space complexity is constant. Thank you so much for taking the time to watch this video. And if this video has helped you, please consider giving it a like and subscribing to my channel. If you have any questions or comments, please leave them in the comments section below. I will try my best to respond to them. Thank you again.